In the 1960s, NASA planned to send people to the moon. To do this, they built a huge rocket called the Saturn V. At the top of the rocket was the Apollo spacecraft. They needed a place to put the rocket together. But the launch pad wasn't the right place for that. So they built the Vehicle Assembly Building, or VAB for short. This building is still used today. It protects the rocket from wind and rain. The rocket stays safe inside until it's time to move it to the launch pad, which usually happens a few weeks before the flight. The VAB has been used to build 3 main rockets: Saturn V, for the Apollo missions; Space Shuttle, for the Space Shuttle program; and Space Launch System, or SLS, used now for the Artemis program, which will take astronauts back to the moon. They started building the VAB in 1963 and finished in 3 years. Gentle music. The building cost $117 million back then. Today, that would be over $1 billion. Over time, they made the area around the building bigger. They also added the NASA logo, known as the meatball, and a huge American flag on the outside. The VAB is 160 meters tall. Here's a size comparison. It's taller than the Statue of Liberty, and almost as tall as the Eiffel Tower. Some parts inside are open all the way to the roof. That's why some people say it's the world's biggest one-story building. But since there are many platforms inside, that might not be completely true. The VAB is in Florida, at the Kennedy Space Center. It's here on the map. Nearby are 2 launch pads, 39A and 39B. Over 5 kilometers away. The long road that leads there is called the Crawlerway. It's 40 meters wide and has 2 tracks side by side. When the rocket is ready, it's carried from the VAB to the launch pad on this road. Huge machines are used to move it. We'll see more of that later. The rocket is made of many large parts. These parts are built in different places across the US. Then they are brought to Florida. Some pieces come by boat and arrive at a place called the Turning Basin. Others come by airplane and land on a runway built for the Space Shuttle. Some parts can also come by train. Once they arrive, they are brought to the VAB. The smaller building next to the VAB is the Launch Control Center. It faces the 2 launch pads. Let's look inside the huge VAB. There's an area called the low bays, used to work on smaller parts. These were used mostly in the 1960s and 1970s for the Apollo program. The taller part of the building has 4 high bays, numbered 1 to 4. These are big open spaces where rockets are built. The building has space on the north side to add 2 more high bays if needed. And the roof can be made higher too. But as of 2024, there are no plans to do this. On the sides of the high bays are towers, named Tower A through F. They go all the way to the roof. In the middle of the building is the transfer aisle. It runs the full length of the building. There are large doors on both sides that open to let big parts come in. The biggest doors are on the high bays. Each door has 4 panels that move left and right, and 7 that move up and down. It takes about 45 minutes to open one completely. The main part of the building doesn't have air conditioning, but when the doors are open, fresh air helps cool it down. There are bridges and walkways so workers can move around, and many elevators to reach different floors. Inside, there are big yellow cranes to lift the heavy rocket parts. One crane moves along the transfer aisle and can carry up to 159 tons. There are 4 more cranes inside the high bays. At first, there were only 2 cranes in the high bays, but now there are 4. The strongest ones can lift up to 295 tons. The crane operator sits in a small cabin high up. They shouldn't be afraid of heights. We'll see how these cranes work in a moment. Now, let's look at how the VAB was used for each space program. Saturn V, the Apollo missions. This was when the VAB was brand new. High bays 1 and 3 were used the most, because they faced the launch pad, making things easier. Inside each high bay, there are large bases called pedestals. On top of these is the mobile launcher and the launch umbilical tower. The rocket is built in stages. The first stage of the Saturn V is brought in. 2 cranes work together. One in the transfer aisle and one in the high bay, to lift and turn the rocket stage. Then the high bay crane lifts it the rest of the way, and gently places it on the platform. Around the rocket are huge platforms, each as big as a house. They help workers reach the rocket and do their jobs. Next, they add the second stage, then the third. Above the third stage is the instrument unit, which is like the rocket's brain. At the very top is the command module and lunar module, the parts that carry astronauts to the moon. During the Apollo years, 3 high bays were used at once to build rockets. When the rocket is ready, the platforms move away and the doors open. The crawler transporter moves under the rocket and lifts it. This is called the rollout. The machine moves very slowly, only about 1 kilometer per hour. So the trip to the launch pad takes hours. Finally, the rocket is ready for launch. Space Shuttle program. After Apollo, NASA started working on the Space Shuttle, a reusable spaceplane. There were 135 shuttle flights over 30 years. The shuttle helped build the International Space Station. NASA reused parts of the VAB but had to make changes. The shuttle was shorter than the Saturn V, so they moved and changed the platforms. High bays 1 and 3 were used to build the shuttle, and bays 2 and 4 were used to store the big orange fuel tank. Bay 2 was also used for safety during hurricanes. Bay 4 sometimes held a shuttle waiting for its next mission. They had to widen the north door so the shuttle could fit in. They also made space for the tail, called the vertical stabilizer. The towers on the launch pads were moved and called fixed service structures. The old Saturn V platform was used for the shuttle and renamed. The solid rocket boosters, SRBs, were built first. They were lifted and stacked on the launch platform. Next, they added the external tank between the boosters. Then the shuttle, or orbiter, was lifted up and rotated to fit. It was attached to the other parts of the rocket. Then the whole stack was taken to the launch pad, just like before. Space Launch System, Artemis program. After the shuttle ended in 2011, NASA prepared for a new rocket, SLS. This would send people to the moon again with the Artemis program. The VAB was updated. Old wires were replaced. The shuttle platforms were removed, and new ones were added in High Bay 3. There are now 10 pairs of platforms, smaller and able to move up and down. The crawler transporter was upgraded. New mobile launchers were built. SLS is very heavy, so it needed stronger support. SLS launches from Pad 39B. Pad 39A is used by SpaceX now. The rocket is built the same way. First, the SRBs go in. Then the core stage. Then the upper stage, which holds the new Orion spacecraft. When it's ready, they do the rollout again. The first SLS launch, Artemis 1, happened in November 2022. There were no astronauts, just a test flight around the moon. Artemis 2 will carry 4 astronauts around the moon, maybe in 2025. It will be the first time people leave low Earth orbit since the 1970s. The vehicle assembly building isn't just a place to build rockets. It shows what people can do when they work together. We can solve hard problems and do things that once seemed impossible.